Hi viewers and welcome to the channel and welcome to another FreeCAD tutorial. Today we're looking at knurling. Now knurling is a manufacturing process. It's normally done on a lathe and we're looking at placing this pattern along this edge. Now there's different types of knurling. We're just going to go for a simple crosshatch knurling on there. Now this is a quick process, but it can take some time if you're on an older machine to recompute. This is the reason why we do this last, like with fillets and chamfers. So this is the finishing process. It's the kind of thing that you'll add to your model during the last phase of refining that model. So I hope you're enjoying the channel. Let's take a look at this technique. If you like this video, please hit a like and also subscribe to the channel. I also have a Ko-Fi site where you can actually donate to my contributions to the community, and that's at ko-fi.com/MANG0. So for this, we're going to create a new document. And from here, we're going to jump into the part design. So everything's going to be done in the part design for this one. You can do this via the part, but part design is much easier to do. We're going to start with a new body and a new sketch and place it for now on the XY plane. We're going to create a circle in here and constrain it to the center. And also I'm going to give this some constraints. So we're going to put a radius in there. And I'm just going to go for 6mm for this one. I'm just going to zoom in and close that. We're going to add some padding to this. So just going to pad this out. And again, I'm just going to go for 6mm, but the dimensions are up to you. So now we have this circle that's been padded. Now the important thing is that this seam here we will be using to mount a datum plane across. So I'm going to click on this line here, this seam. You can see that's called unnamed body.pad.edge1. And we're going to come up to create a new datum plane. That will place that datum plane basically on the bottom there, but we need to place it along here. To do that, we come down and rotate this around on the y-axis to 90 degrees. That will place that on there. If we zoom out, we can see that datum plane has been placed along there. Now we may have to click on the flip sides for this one, because when we come to sketch upon this, our sketch may be sitting behind the object, so it'll be on this side. But we'll have a look at that. Basically flip sides, if I enable that and go back, hitting OK, looking at the model, that datum plane, we come down and we've got map reverse. And you can see that's set to true. And that's what the flip sides does, it sets that to true. If I place a sketch upon here, and I'm going to connect it to the datum plane, so I just clicked on new sketch, datum plane, you can see that's on the right side of that object. If it was on the wrong side, all we have to do is come into the datum plane and change the map reverse there. Or if we look at the sketch, we've also got the same on here, map reverse. So you can either reverse the datum plane or reverse the sketch. Now we're in the sketch, I'm going to come in and I'm going to sketch an angled line across here. But first we need to know some parameters. We already know the radius of this is 6mm. So we need to work out the circumference. When we've worked out the circumference, we can space a number of geometry across that and evenly space it across that surface. Now to calculate that, we're going to use a simple formula, and if you type in circumference of a circle, you even get this solver here that Google throws up, which is quite handy. Now our radius was 6mm, and we can see that we get 37.7 there. So we can take that, and whatever we divide this by will give us the millimeter width of the geometry we need to create. So I'm going to create an angled box, an angled rectangle that we can remove material with. So I'm going to come into here and just place that in there. And I'm going to divide it by first by 90. Let's see how much we get. So that's 0.418. So that's make something on our object. That's that size. For that, I'm going to make the slanted box, as I said. So this is just going to be basically a rectangle, but I've got the auto constraints on. And what we've done, if I escape out, we've made two sides, a vertical and a vertical, and we've just auto constrained that to this vertical line. And we need to make these equal. We need to make this one and the line in here, if we can see it. So that's click on model, click on the datum plane and hide it. Now I don't think we've actually got a line in here yet. No, we can see if we put some side on there, we can see no lines in there. Let's just create a line in there. There now is a line in there, we can see it sitting there. And we need to make this one and this one equal. And also we need an angle across here, an angular constraint. So that horizontal line and that line there, let's put an angle on there. We need a 45-degree angle, but our angle's gone this way. So 180 will be flat, and can do, in here you can do minus 45. So it's a simple calculator. Obviously you can do that in your head, and we get 135 degrees. Now you can see this is all over the place at the moment. So we need to connect up these points and make sure these two are connected up as well. Also we need some length. So we need to create some length in here. And we'll put some height in a moment. So let's create the length, which we're going to use fixed length, this line. And I'm going to set that to something like 2 millimeters. Now we can set this length here. I can do it either the front or the back, it doesn't matter, they're both the same. Let's click that line and place a vertical. You can see it's been locked down now. And we'll have a look at what we've got. We've got 0.418. So let's try this. 0.418. Let's have a look what we've got. So we've got this size now. So if we think if this was pocketed in here, is it what we're looking for? Is it a bit too big, or is it okay? I'm actually going to go for that. I've decided that that is fine. So let's pull these constraints out a bit so we can see what they are. Remember, you can pull these off the line so you can see them. So we know that we need to make 90 of those to fill the whole surface, but we need spaces in between, so we just need to divide that by 2. So that would be 45. Let's go back. First thing we need to do is come out of the sketcher. Let's close the sketcher. Get ourselves positioned and use the pocket. We can see how far that pocket's gone down, which is a bit too far. Let's come over to our pocket parameters and place something in like 0.1 and have a look. I'm happy with that. That's okay with that. So that pocket's there now, and we're going to come up to the create a polar pattern feature, also available from part design. Apply a pattern, and we've got polar pattern there. Click on that. It's going to ask for the axis that we want to do the polar pattern around. So at the moment this is normal sketch axis, so polar pattern will go around this way because this is where the sketch actually sits. It sits on top. So we need to change this to Z, because our Z axis is this one here. You can see it saying Z axis there. And then we can adjust the occurrences. So we go 20 on here. We can see them all going around here. So we need 45. As you can see, they fit all the way around there, and you've got the spaces in between. So that is our first pattern. Now we need to crisscross the pattern. There's a number of ways of doing this, including mirroring the sketch. You notice I started with this sketch. Not constrained to the center in the middle, but constrained here. So we can easily mirror this over here if we so desire. So we have the first part of our knurled surface around that object. We need to make a crisscross pattern now. We can leave it like this if we so desired, but I'm going to mirror the sketch over and crisscross that pattern along there. To do that, it's quite simple. We're going to come in and find that sketch that we used. So it's this one here. Press the spacebar. It's part of the polar pattern. Now it's the pocket. So if we look along here, we can find our seam and we can see the sketch there. As you can see, the sketch and the polar pattern that is produced don't coincide, and that's because of the depth we've actually removed from there. We've only removed 0.1 of a millimeter along there. If I remove more, that will go deeper. The reason why is because, as you can see, if we can just place that in that position, you'll see, we look, this is a curved surface and this goes over that curved surface. And we can see it ramping out of this surface here. If we increase that depth, then we would go up to this point here. So it's up to you. If you want to go all the way up, we just increase the depth. I'm going to leave that as it is. We're going to take this sketch and I'm going to duplicate that sketch. But I'm not going to use the edit duplicate tool, which is here, duplicate selection. I'm going to mirror that sketch so it mirrors across this line here. This is the reason why we've done it across this seam. So let's go over to the Sketcher tools. Now in the Sketcher tools, we'll select the sketch, go up to sketch and go to mirror sketch. Now it's asking us for the axis. We're going to mirror it over the x-axis. The x-axis is pointing straight up at the moment. Let's OK that, and that mirrors across there like so. The trouble is we can't actually do anything with this yet because A, it's outside the body, which is easy to solve. So I've just collapsed the tree view for the body and we'll just place the mirror sketch in there. And also if we come into the part design and try to pocket that sketch, so let's make sure it's selected first. Try to pocket that. We can see that's not going to take. If we hit OK, saying pocket result has multiple solids. This is not supported at this time. That's because if we look at our sketch, what might be happening is that you can see we've come in a bit there. When these pocket, it removes material. So what might be happening is a little bit of the body is being missed at this point here, causing the pocket to fail and creating two solids in there. So we're going to come into the mirror sketch. We're just going to adjust it a bit. So at the moment it's over these points, but it's not attached to them. So I'm just going to pull this slightly over. But you can see the constraints are gone because of the mirror. So let's just Control Z that. Let's just use a vertical constraint on that. And come in here and have a look, see what we've got. We can see that's sitting over there at the moment. So what I'm going to do, just Control Z that. We've got a length on this from here to here, and those are equal to each other. And this sketch is mobile, as you can see, but we've lost the angle constraint on here because obviously our angle constraint can't come over. I'm just going to nudge this slightly this way, just to off that point, and perhaps place that on here with a point to an object constraint like so. I'm going to close that. I'm going to try pocketing that now. So just click on the pocket. We can see that has pocketed. So that is our problem. So now we know the problem, we can cancel that pocket and come in and just adjust this and add some constraints in here. So I'm going to take these two and just add our angle constraint back on. It's 135 degrees. Close that. Let's try pocketing that. So that's allowing our pocket. And we can do this at 0.1 millimeters, the same as the other. Now I've got our pocket in there. We can go through and add the polar array around there. So again, in the part design, click on that pocket and come up to the create a polar pattern feature. Now if we look at our model and look at the polar pattern in here and look at the data, we can see the occurrences was 45, so we've got to replicate that in here. Go up to tasks, it's still open, making sure we select the z-axis that runs along here, z-axis there, and change the occurrences to 45 and click off. You can see that polar pattern has taken. And we've got the knurling going around here. Obviously, if we increase the depth, we'll get a different effect depending on the pattern we want. So at the beginning of the demonstration, the one that I showed you there had a different depth and a different width. Also a different amount of occurrences around the edge there. We can see those are coming in there. If we want to change those occurrences, then we can come into the polar pattern and either change the occurrences here, but we must remember that we're going to have to change the width of our geometry inside there. We also can change it by the pocket. So at the moment we're taking a length of 0.1 there. If we change this to something like 0.2 and click off, that will recalculate. As you can see, it's gone a lot deeper in there. We've got a different look and fill, and we'll just do the same to the other pocket as well. And as you can see, we've got something that more represents the demonstration piece that we showed at the beginning, just by changing those depths there. And we can come in and hide this sketch here just by pressing the spacebar. Now this is quite a processor intensive operation, so this needs to be really done last, the same as you would do fillets and chamfers in there. So we can do that last. One thing to remember though, if we come into the sketch and come back out of it, so if we change something in here, obviously it's parametric, so that will take an effect, but even coming into the sketch and just closing, it will cause it to recompute. As you can see, that took a little while to get out of there because we recomputed not only the sketch, but we've recomputed the polar pattern and the second polar pattern on top of that. To stop that from happening, we can put the project into mode to stop the recomputation. So to do that, we come up to the main document, the first master node in our tree view, and we right click, come down to skip recomputes. That means we'll have to do the recomputes manually. So when I go into this sketch now and come in, and if I changed anything in here and press close, what will happen is you'll get a little tick by the side of the sketch saying that it needs to be recomputed, and we can recompute that just by going to edit and refresh. And the same if we came into something like this polar pattern here, this mirror sketch. If I did the same in here and close that, then we get a tick by there as well. So now I can go to edit, refresh, the whole document will recompute, and you can see those have all taken effect, and we're back to where it was before. To turn this off, we just come into the project document there, right click on it, and just uncheck that skips recompute there. So that's it. That's how to make a knurled surface, like so. Obviously you can use any pattern you want along there, but the process is the same. We can even use this side to create a knurl surface on, so we're cutting into the object at different angles from this side. So I hope you enjoyed that, and please look out for some more tutorials during the week. We're still doing our curved surface tutorials in there, and we're going to start looking at animation as well in the future. Thanks a lot, and I'll see you again. If you like what you're seeing, please subscribe to my site, and also I have a Ko-Fi site where you can actually donate a few pence or a few pounds, dollars, or whatever your currency is, and that's at ko-fi.com/mang0, and there you'll be able to help me fund my site, and all the money that I actually get from any funds will actually get pushed back into the channel. Thanks a lot for watching and subscribing. I'll see you next time.